And how you going? Welcome back to the bench. We're going to have a look at the YiHi SXmini Nano. Now, I'm ashamed to say I've had this for so long and I've just never gotten around to doing a video on it. So I'm really sorry, YiHi. It was sent to me by YiHi kind of via my mate Aussie Geek Vapor. So thank you guys, and I'm really sorry I just haven't got around to giving it any sort of attention at all. But here we are, better late than never, hey? So we're going to have a look at it. Now, it's a cool device. I reckon as far as innovation goes, it's one of the more interesting devices I've seen for quite a while. Auto squonking, temperature controlled pod. So it's actually got a little pump inside it. When you hit the button, it automatically pumps liquid up to the atomizer. And that's not the only thing that's cool. It's kind of like an RTA head on there, but they're pre-made coils. So you don't have to wick them or build them or do anything. You just buy these little guys in a pack and you just plug them directly into the atomizer and you're good to go. So you're really getting a pretty sophisticated vape here. Being a temperature controlled device, you don't actually set the wattage on this guy. You just set your heat level. So you've basically got like a cool, medium, and warm setting. Same as with the pump, you've got controllability over the pump. You can set it to lower or higher. When I was using it, I just set the pump to flat out. It seemed to be fine, but I like the coil to be like quite saturated, kind of on the verge of too much. Just personal preference. Now, I don't know, that might deter some people that you can't set your wattage exactly on this guy, but I mean, I think as far as the settings go, if you're using a pod anyway, you normally don't have any controllability over the actual temperature of the coil. Some have got selectable power, but most don't. I can't think of any other small pod mouth-to-lung devices that do temperature control. The only thing I found a little bit disconcerting was the vibration of the pump when you push a button. So obviously you push a button to take a vape and you can feel that pump whirring, which is just like something you're not used to ever with a device. You're not used to that sort of vibration. So if you kind of forget about it, you go to vape and you're like, oh, what's it doing? Like, you think it might be doing something wrong, and then you remember, oh yeah, no, it's the pump thing. Yeah, that's fine. So you can unscrew the atomizer on this guy, but it is not a 510, so you can't go and put a different squonking atomizer on there. And there's a little built-in tank. Ooh, some crusty old liquid in there. Let's not look at that. You're getting basically a rebuildable, auto squonking, temperature controlled, high-end kind of vape, and there's really very little you have to do to make that happen. All you have to do is stick liquid in it, really, and hit the button. So yeah, pretty cool. Now, things I'm interested in is how the pump works, and I would like to see how much power that pump actually uses. Because it's only a 900 milliamp hour battery in this guy, it's not a huge battery. It's the same as a small pod, really. So obviously any power the pump is using is getting subtracted from what you can use to actually vape with it. And all the normal stuff like build quality, have a look inside. We're going to go a little bit further on this guy as far as testing, because I think we kind of owe it to them. We're going to have a look at the battery capacity. We're also going to do a test on the charge function to see how well it charges. All right, let's start pulling this thing apart. Ew. Ooh, a casualty. So I'm just kind of going for where the biggest gap is. I can see around this edge between the panel and the actual mod body. That is an adhesive plate. I'll just get him off first. Okay, so if you take one of these apart, just go a little bit slower than what I did, because I've bent that a little bit. So yep, just go nice and easy. Lots of adhesive on the back here to hold that plate on. That is a metal plate, but this guy is a plastic frame. And now with that plate off, we have got access to the Phillips head screws underneath. I keep forgetting to mention, if you guys haven't heard of Battery Mooch, please go check my description for links to his work. Become a Patreon if you can, because he's doing awesome work and we would just be stuffed without him. He's basically the authority on cell testing. He tests all the removable cells. 21700s, 18650s, all the different models. We wouldn't know what they're actually rated at and how they perform if he hadn't done all the testing he has. As I said, become a Patreon if you can. Just a couple of bucks a month really helps him. He's trying to do this as a full-time job for the community. So anything you can swing his way would really help, and that would mean we have more access to the information we really need, because this is safety stuff. Not only safety, but also performance. You know, you want to know which is your best battery. Go check him out if you can. And if you haven't heard of him, like, what rock have you been under? Okay, last screw out. And we've got the inner plastic plate comes off. There's our goodies underneath. Lipo cell, we've got the pump there. We've got the circuit board up here. Associated tubing we need for the squonk system. Pretty neat. I'm not seeing a whole lot in the way of liquid protection here. There's not really any seals. So, okay, we have got this plate on the outside. Hang on, I've got that the wrong way around. So there's no real seals on this inner plate or obviously that adhesive plate. So it would probably be possible that if you did spill a lot of liquid down the side of this mod, that liquid would kind of wick into that gap and eventually get its way inside the device, which would not be good. You know, I'm always pretty hard on liquid ingress protection just because it really does kill mods. I would bet that it's the #1 cause of dead devices. Devices failing, I would pretty well put money on it'll be liquid ingress. So we would prefer to see seals around this plate, but there aren't any. So it's not great. Just pop that battery out, which has got a bit of adhesive holding it down. And that's a pretty chunky battery for a 900 milliamp hour. It doesn't look like the usual kind of Chinese cells, which are more often than not, they're that kind of silver outside with capped on tape on them. It kind of reminds me more of a hobby cell that you find for remote controlled cars and things like that. 3.7 volt standard voltage single cell lipo pack prismatic cell, and we are labeled as 900 milliamp hour, so that's good. We're already at least rated as what the device claims. Instead of waiting to the end, I'll just put the test results right now on the CBA, and thank you future me for testing that. Yay! We got 856 milliamp hour on the capacity test, so a little bit under the 900 we were hoping for, or a bit over 900. But I'd have to give it the benefit of the doubt, I think, in this case, because this cell has been sitting in the device for the last year, or maybe more that I've had it. So there's going to be a little bit of capacity loss there. And also, I don't know how many cycles I actually did when I was using it, like maybe a dozen, maybe more. So yeah, a bit of an element of doubt there. So I think overall I could probably say it would have been around about 900 milliamp hour when the cell was brand new. Overall, I'd have to give this cell a pass. Seeing some conformal coating on the board around the components. So it's quite a thick coating. Normally the conformal coating I see on boards is quite thin. Like you really have to put the UV light on it, or you have to notice the shininess of it, not the actual that it's built up in areas to be able to see it. And this, you can see it clearly lumped on, which is really good. I think that conformal coating will be better at protecting this device than the standard conformal coatings that you see on these sort of boards. But yeah, note that they do just concentrate the coating around the components and they don't bother slapping it on the whole board. I mean, it is a really good idea to have a coating on a board here because, you know, we've got liquid running right through the mod. So if this pump ever gets a leak, or, you know, there's ever an issue with a tube or something like that, maybe even the atomizer connection, if that ever had a leak, of course, you know, it's right in the way of the circuit board. Pump has some very soft foam on it just to keep it from rattling, I'd say. The pump's not screwed down or completely fixed in place. It's really just located in that section. It's just held down by that plastic plate and the spot that is molded for it to sit in, which is fine. All right, let's go ahead and get the board out. Now, again, I never recommend people taking things apart if they don't know what they're doing. But just remember, if you do take something apart, I mean, it is better to take the battery power off first. You really should do that first if you can, like desolder the battery. Because I'm mucking around here with taking screws out and using metal tools. Well, there are things that are always connected to positive on this board. So, and there's a lot of ground track as well. So if I get this in the wrong spot, it can short the cell out, which is really bad. And obviously be very, very careful with the cell as far as physically handling it. You have to be really careful not to puncture it or poke anything sharp through it, because that's just instant, very bad stuff happening. What I want to do actually before I take this completely out is test. I'm going to test what current and voltage is going to this little motor. We've basically got a very tiny little motor, and then the pump section is actually attached to the front of it. Power input to the motor there. Interesting little assembly. What a cute little motor. Like it's tiny, you know, you can see the size of my thumb compared to it. It's just tiny little motor. I would say this would probably work on 3 volts directly. So it's probably just getting switched cell voltage. Let's see if I can do this without shorting anything out. Yeah, about 3.2 volts. So what we want to do next is desolder this connection off the motor, and I'm going to put an ammeter in line. Then we'll see the current going to the motor. Then we'll calculate the actual wattage going to it. Say you're getting like 12 watts to the coil, and this thing might be taking 2 watts. I don't know, no idea. That'll at least give us like a percentage of how much power you're using to power that pump compared to the coil. Done a crappy job at desoldering that. There we go. Come on. Okay, I'll solder a little extension piece of wire on here. Look, my screen's going all weird. What the hell happened there? So we're connected to the BK meter, the bench meter, which you can't see. Unfortunately, you're just going to have to take my word for it. It's around about 350 to 400 milliamp. Actually, no, it's not. What? 30 milliamp? That's nothing. Kidding me? That's only like 35, 40 milliamp. That's way lower than I thought it would be. Just going to set max on the meter so it'll capture the highest current draw. Okay, highest current draw, which would have only been a peak as well, 41.8 milliamp. So let's say 40 milliamps. So 0.04 times 3.2. That's the wattage. Well, I'm very surprised. 40 milliamps at 3.2 volts ends up being 128 milliwatts. 0.12 of a watt. Very low. So that's very surprising for that pump to draw such a low amount of power. Having that pump in line is really not costing you any battery life, you know, with regards to 12 watts or 14 watts or whatever you're vaping at. No, negligible. 0.1 of a watt. Who cares? Doesn't matter. So let's get in and see what the actual pumping mechanism is. Now, first thoughts about pumping e-liquid is that it'd have to be a certain type of pump that's really not contacting the liquid. You wouldn't want your liquid actually touching moving metal parts because, you know, obvious reasons, your chance of getting metal and stuff in your liquid or grease from bearings or other crap like that. So there is a type of pump called a Peristaltic pump from memory that can pump the liquid without touching the liquid it's pumping. We've got some screws on the outside here. So we have 2 tiny little Phillips on the end and 2 more Phillips holding the motor to the pump section. So yeah, let's get apart, see what's in there. Ooh, exciting. Ooh, should we do a zoom? Okay. Ooh, can we see that? Back in frame. So there's the motor disconnected from the pump section. Plastic drive, but that doesn't matter because it's, you know, it's such a light duty little thing it's doing. And very low power, very, very low power motor. Such a cute little pump. Look at this guy. I don't know what kind of drive you'd call that, but it's like a plus symbol. This is the shape of the drive. Corresponding drive section on the pump, and that is actually metal. Looks like it is electroplated. Not sure what the base metal is, of course, but I'd say probably not stainless steel. It doesn't look like stainless. Let's get this little guy apart. Let's not lose that screw. Oh, look at that. Oh, very cool. It is a peristaltic pump. Let me get that off the board before I short something. Interesting. Very cool. Yeah, okay, so what's happening is you've got this center section here that's driven by the motor, and it spins around with these little roller guys, and the squonk tube is just coiled around it, squished by it. So as it rotates around, those little rollers are just squishing that tube closed and kind of pushing the liquid through. The tube coming up from the squonk tank is not going through any sort of pump mechanism, like it's not in contact with any metal at all. It's literally just a tube straight through, and that's great because the liquid's going to be staying clean, no risk of any contamination or anything like that. It's just kind of a little nylon bushing, probably not going to wear out in the lifetime you're going to be using it. It's either nylon or it'd be a certain type of plastic that is made especially for that kind of job. This inner guy actually does look like stainless steel. It's just got that different color to it than the outside, which looks more electroplated. Yeah, and overall really cool system. That's amazing. Look at all these little bits and the cute little motor inside. That's what's doing all the pumping. Let's get this atomizer connection out, which is not a T5, that's smaller. T4 on the atomizer screws. Just 2 screws holding it to the plastic frame, which is not a lot. Those screws go down into the plastic frame, but in the plastic frame are some inserts, which is good, threaded inserts, which are metal. Right down in there. Looks like a brass insert which goes into the plastic, which is good because I would not have trusted these screws. If they were self-tappers into the plastic, there would have been some marks off there because I don't think 2 screws are going to really hold it in plastic if it hits the tank if you drop it. But the inserts in the plastic should be better, they'll be stronger. Sealant around the atomizer connection, which is nice. Sealant where it goes down into the tank there. More sealant on the wires that go to the motor as well. So there's some manual touches here that they've thought about. I'm going to pop off this side to see what's here. The screen is pretty well retained actually. So the molding is quite nice in the plastic to hold the screen in place. And look, there's 4 little dabs of sealant in the corners there. They might have a little syringe or a little squirty thing they can just go bop, 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 and put 4 little dots of sealant in there before they put the screen in. That is definitely a nice touch, just to retain it, make sure it's not wobbling around and breaking connections and stuff like that. There's no seals on the atomizer connection as far as the body into the mod frame. So if you get liquid spilling down the side here, like over the base, over the atomizer, it can wick down into this area, because like when you have 2 surfaces together and you've got liquid there, the liquid tends to want to wick down into that gap. So if there's any sort of gap, even if it's pretty tight, if it's not sealed, the liquid will kind of want to go in that area. There's no O-rings or gaskets or anything else to prevent liquid going down. It should be fairly low risk thinking about it, just because you kind of can't over squonk because it's controlled by the board. And when I was using it, I found it didn't over squonk even at the maximum setting. It was fine. It never got to the point where the atomizer was actually like flooding and coming out the airflow holes or anything like that. So probably the risk of having liquid coming out and getting into this area is lower than most mods. Yeah, I'd have to say still points off and not putting any sort of sealing or little gasket or O-ring or anything in there. We've got good sealing on the board, but you know, it's better that it just doesn't get in that whole area to begin with. Here's one I prepared earlier. There's the board out of the mod, and that frame that I thought was part of the molding in the case is not. It's more like one of those frames that go around the screens like in other mods, and they have pegs that go through the board, and then the pegs just get melted onto the board to retain it. But that's good. That's really good. It's nice and firm. The screen's not going anywhere. These buttons are a bit interesting. Tiny. They're kind of strange buttons. It's almost like a tactile switch without all the casing and assembly around it. It's like you can actually see the disc that is flexing when you push that button to give it the kind of tactile feel. Difficult to say how durable these guys would be. There's kind of the more heavy duty switch that we see on boards, and you can see it's a lot bigger than that tiny little guy on the SXmini Nano. And on some mods you get these smaller tactile switches. Even they're quite a lot bigger than the one on the Nano. And it's the same with the up down buttons as well. So yeah, that's an interesting little switch. Very, very, very low profile. You can see how chunky in comparison the normal tactile switches are to this guy on the board. Is just super slimline. I don't know how these would be with liquid ingress. Inside these switches there's a disc that's kind of curved, so when you press on it, the disc actually goes from being like that, it flips inwards, and that's what gives it the click. And you can actually see the disc sitting there, but there is a membrane over the top of the disc, maybe sealed. It's hard to say, kind of hard to say. These guys normally aren't good for liquid ingress because that's hard plastic and liquid can go down inside them and get into the contact. These guys are normally better because that is silicon inside and it's just sort of inherently sealed. Because it's pressed together against that silicon layer, it'll prevent liquid from getting into the contact. These guys, I don't know. I haven't really had any experience with these switches or how reliable or durable they are. So I guess we'll leave it at that. The fire button itself has a built-in silicon layer which keeps it steady and stops it from rattling. The smaller buttons here have a bit of foam around them to keep them kind of steady. It's an ST microcontroller, which is a really good name brand. And looks like an STM32. Okay, so I'll put up the testing for the charge circuit and I will explain in the voiceover how well it did. The charge circuit I see is this guy circled in red. Unfortunately, unable to get a number off it, so I don't know what model it is. Just on the back side of the board, behind the charge IC, we've got a pad here which is uncovered. Now, what this guy's doing is actually heat sinking that IC, which is a really good thing. You can see the little holes on there. They're actually through-hole vias, they're called, or vias. And they allow heat to wick from the charge IC through to that ground plane area, and that allows some heat to get away from the IC, which is really good, keeps the temperature of the IC down. We want to keep that down below a level where it's going to shorten the lifetime of the IC, which some companies really run them right at their maximum, which is not great. And testing this guy after 30 minutes of charging and covered, I found it sat at a maximum of 66 degrees on that back pad. Even around the front on the IC itself, it was slightly cooler, and we can see that the heat is actually getting through to that pad. Hence the higher temperature than on the epoxy case of the charge IC. It's great to see they put in the effort to thermally design the board to protect that IC and keep the temperatures low, because that keeps our reliability high. which is excellent. Good job. And if you want to see what perfect lithium ion charging is supposed to look like, this is basically it. This is really, really good. Excellent performance. So we'll go through the stats. First of all, we have a maximum charge voltage of 4.191 volts, which is absolutely perfect. We're supposed to be 4.2 plus minus 1%, 947 milliamp of cell charging current, which is fine. I don't like to see really any higher than a 1C rate for these small cells. So basically what the capacity of the cell is rated at, I don't want to see it much more than that as a charge current. So being a 900 milliamp hour cell, 947 is as quick as you should get it without impacting the cell life too much. So that's fine. It's good. It's doing that with 982 milliamp of USB current, so 1 amp and above. USB adapter would be perfect to use with this guy. The charge circuit efficiency varies from about 65% at the start up to about 78%. It's normal that it does vary as the cell voltage rises and the circuit is putting out a different ratio of voltage and current. So yep, that's fine. Not too bad. And the circuit does a proper cutoff at 95 milliamp. That's as it's finishing the constant voltage phase. Well regulated current through the cycle here as the circuit is in the constant current phase, and then we get up here where we switch into constant voltage phase. So the circuit's holding the cell voltage pretty much constant, and it's allowing the current to drop. And as it drops, that's it, basically the cell getting topped up, sitting at its maximum voltage. And then once that current has dropped down to our 10% cutoff, circuit does a proper cutoff, basically disconnects the cell from the charge circuit, and the cell is just resting. You see a slight relaxing of the cell voltage, which is exactly what's supposed to happen as the cell current goes to 0. Now, very good thing here is that the cell current is not going negative, because what we see sometimes on some circuits is that the USB power can't power the standby of the board when it's still plugged in. So the board basically stays in an active standby mode where there's current getting drawn from the cell, which means the cell voltage is dropping. You're actually discharging the cell, and then the circuit's having to kick back in to top it up once it gets too low. So what happens if you leave it plugged in too long is you get this constant small discharge, cell voltage dropping, hits a level, pumps back up again, starts dropping again. You get this constant spikes of current as the cell is constantly being topped up, which is not great. It's not supposed to do that. In this case, the Nano does not do that. The cell current goes exactly to 0, which means you can see the USB current here is what's supplying the board with its own standby, which is excellent. So overall, combined with the low temperature of 66 degrees maximum on the board during charging, the graphs and the current levels and the voltage levels, all perfect. Very, very good. Cannot fault it in any way. Very good job. Overall with the SXmini Nano, some good things, some not so great. I'd say for liquid ingress, and there's not really any seals through the side panels or on the atomizer connection, so kind of at a bit of a risk of liquid getting down into the device. We've got a good thick conformal coating on there, which should help it, but it shouldn't be relied upon. You really should stop liquid getting into the device first. The pump, I think, is a really cool assembly. Very cute little motor and a peristaltic pump, which means the pump mechanism's not actually getting into the liquid at all, so there's no risk of contamination for your liquid. Draws very, very little power, 0.128 of a watt, so basically negligible. You don't have to worry about the pump using up a whole lot of power. That would be running your battery flat sooner than it should. There's nice attention to detail. There's sealant placed in certain areas to help seal everything and retain wires, and the battery performed well, so that is good. And the charging was actually really good, so no problems there either. Alrighty, that'll just about do it. Thank you very much for watching, guys. We'll see you next time.